probably a fairly dry landmass. The browns right at the bottom, dimly seen through the clouds, indicate a dry landmass, some semi-desert, or at least not a wet landmass. There may also be some dust in the atmosphere. Hard to recognize quite where we are. Nice example of the difference between high cloud, which is most of what you see, and the low cloud catching the light at the bottom of the picture. There's a river coming into the view near the right-hand side at the top. That has the look of the Rio Grande in New Mexico. Or maybe it's a river in northernmost Mexico. The dark lines are forested mountaintops, we can say that for sure, and the redder, lighter areas are the plains where there would be ranching and farming activities.
Rock formations below, is that what we're seeing in that area?
Yes, here you see two circles coming into the top of the view now. These are either volcanoes or effects from inside the Earth producing circular features. We think this is the Big Bend area of Texas.
Big Bend National Park.
Big Bend National Park, and that I'm pretty sure is Lake Amistad on the left, and all the lines are a heavily modified geology produced by the continents bumping into one another, and so those are the up-pushed parts which are now high and covered with trees, so that they look dark green. Another lake right in the center, so we're in northern Mexico here, moving southeast. Don't recognize that city on the left side, the bright patch, but it seems to be on the Texas border near a lake. The city of Monterey is on the right-hand side next to those strongly foliated dark lines of the mountains. Monterey is the second largest city of Mexico with a big iron and steel industry, huge population there. And here comes a cloud mass related to a jet stream, probably. And here comes the Gulf of Mexico, top left, with the Laguna Madre, as it's known as, the lagoon just on the inshore side of the coastline, just south of Brownsville. This would be. The view is going rapidly down into Mexico towards Tampico and Veracruz. Local rivers bringing sediment into the sea and producing a lighter blue close to the coastline. Here we're flying out over the open water of the Gulf of Mexico, the westernmost Gulf of Mexico, also called the Gulf of Campeche locally. The trend of this track should bring us to land quite soon in central and southern Mexico in the Yucatan area.
The crews use a camcorder for high definition television on board, This is a very steady view, so obviously the camera held somewhere for this one, but you see some that are obviously the crew holding it by their hand, shooting imagery out the window.
Yes, it's nice to think of them interacting with the planet this way, but it can produce some jiggles in the photography in the video. So we think maybe that they secured the camera in these very stable views. Am I right there, James? Big sediment plume here in the Gulf of Campeche. That's in southwestern Gulf of Mexico. Playa del Carmen is the little town on the island, that long thin island on the left of the view. An oil producing center. This is the center of Mexico's oil production, onshore and offshore. So we're proceeding here southeast across the Yucatan Peninsula, which is very often under cloud, as you see.
The obviously imagery of Earth is taken by a variety of sensors and remote sensors and satellites, in addition to the astronaut imagery collection that is gathered on shuttle and station missions. What are some of the benefits of astronaut imagery?
The first one that comes to mind, just as I look at this, is the effect of the viewing angle on the sun glint point, which reveals so much about exactly where, I mean, to a level of very high definition, exactly where water is actually to be seen. And of course, patterns within the ocean are really only seen in sun glint. I think there's one sensor that can do the same kind of thing, but the astronaut has the ability to look around and see features and do it in a dynamic way and choose for us. We get a lot of data, and if the astronaut acts as the kind of sieve at an early stage in the data collection, we receive much less data, but the quality of the data is much higher because it's been processed by a human, so to speak.
Much more of a discovery mode.
Yes. Here is the Gulf of Fonseca, which is a gulf in Central America. So this is the Pacific coast. We're flying out into the Pacific right now, and this might be Guatemala, lower left, southernmost Mexico, moving on into Honduras. You can see a coastline coming in at the top of the view. This is, I recognize these peninsulas, especially the one coming in right at the top of the view, as the Nicoya Peninsula of Costa Rica. Our Costa Rican astronaut has gotten us all interested in the country of Costa Rica. Some cloud out in the Pacific Ocean on the right there, and features within the ocean. You can it produces a variegated kind of look to the ocean surface, which you just don't see way out of the sun glint point. If you look top left, you don't see any of those features in the sea at all. And the next little peninsula in Costa Rica is coming in far top left, which is the Osa Peninsula with lots of cloud. The land surfaces almost always have a lot of cloud on them in Central America.
Of course, your office trains astronauts prior to their flight for Earth imagery. Just briefly, what types of training are they given? What does that consist of, really?
We give them quite a variety of training. We talk about cities, obviously, which are relatively easy to see. We talk about river patterns. We talk about impact craters to do some planetary comparisons to help us understand what we're seeing on Mars. We look at icebergs. We look at ice sheets in South America, North America. And of course, we look at lots of ocean features. I've mentioned the sun glint capability that the astronauts have, and